Hello and welcome to this new video into which we will see non-linear fitting. The fact is that in point clouds, in Bivariate statistics, some point clouds don't show a straight behavior of y with respect to x, but a curly one. And the cloud is thin enough to try to find a curly regression. So you have to perform a variable change this time in order to go to a new pair of variables after having replaced one or the other or both of the initial variables. The purpose is to establish a linear regression, a linear fitting on the new pair, if the variable change is good enough, of course, and then to obtain a final curved model of the initial relationship between x and y. We have to see that on an example because it's a bit theoretical here, of course. Let's take the values x and y here, 2, 3, 5, 8, 9, 13, 28, 70. It seems that indeed the variations of y accelerate compared to the variations of x. Maybe. Let's graph it, and then yes, we can notice that there is a curly point cloud here and not a straight one. Of course, on 4 points only, we can't perform statistics. Okay, that is just for the example to simplify the calculations or the show of the example. Um, we have to perform some variable change. What does it mean? Maybe if we change the shape of the parabola, if we want a parabola to fit this point cloud, if we want to change its shape into a straight line, well, maybe a variable change like t equals x squared could be a good way. If you are replacing x by x squared, think of the graph, okay? You will change the labels of the graph and the scale, and maybe, and it's a fact, your parabola will be transformed into a straight line. So that's the key point here. Of course, the exercise will tell you to perform this variable change or this one, but as a statistician, you would have to make a choice, okay, to use maybe a power formula, a power function, so like x squared or x cubed or x to the 2.8, why not? Or an exponential function or a logarithmic function, and so on. So you've got an infinite variety of possibilities. As a choice, the exercise tells you here what to take. Well, let's calculate the values of t by squaring each value of x, and we will obtain that. So if you're told to perform a variable change, it means that the new variable will replace the old one, okay, the former one. T equals x squared, t replaces x. A point here concerning the calculator. A right use of calculator, a correct one to save time, would be to use lists in order to calculate the values of t by itself and not by yourself. There exists list formulas on calculator. So if you go, sorry, on the stat mode, you can enter the values of x in list 1, the values of y in list 2, and then you will have the possibility to make your calculator calculate the values of t in list 3, for example. Just go to the location on top of list 3, okay, on the title, list 3 or L3 for Texas, and at this place you can type a formula, which would be here list 1 squared, okay? Because in a list mode on your calculator, the calculator doesn't understand x or y or whatever, what variable. It only understands lists, okay? And your x has been entered in list 1. So you are asking list 1 squared in list 3. And on top of list 3, it's very important. How to write the word list on a Casio? By shift 1, okay? The quickest way. On Texas, you have to press the keys second one to type directly L1. Well, once it's done and validated, you will obtain directly the value of t. Now, we have to perform the point number two of the methodology, a linear fitting of the new pair. We are working on the pair ty. Yes, it seems that the evolution of the values of t follow better the evolution of the values of y better than x does or did. In a new graph with ty, we can see that indeed the points seem to be close to be collinear. Well, let's perform a linear fitting that consists in finding an expression of a straight line in the second graph. You just have to ask it to your calculator, which will use the least square method, and will give you the coefficients a and b. We saw it on the previous video, so I won't explain all the details of that. Okay, so using the least square method, so the calculator, you will obtain a equals 1.025 and so on, and b 3.856. By the way, a comment, you have to settle your calculator correctly to obtain the right coefficients. You are performing a fitting on the pair ty. That means for the calculator, list 3, list 2. Okay, so the first variable will be list 3 and the second one list 2. Well, afterwards, we're going to the last point of the methodology, a final curved model. We want the expression now of the parabola in the first graph. Well, that's very simple because t equals x squared. So you just have to replace t by x squared in the expression. Okay, so you have to make a change of the writing in the expression. And this is a quadratic expression that is the correct expression of the correct parabola. If you draw the parabola, you will find that, yes, it follows the point cloud. Okay, let's see that in an additional example to see it again. So I'm putting back here the methodology. The exercise 15 of my document introduces the study between the speed of a motorcycle in kilometers per hour. First variable x, so 10 kilometers per hour, 20, 30, 40, and so on. And below, the values of y are the consumptions in liters per 100 kilometers of this vehicle. So, as you can see, the values of y first decrease and then increase. So it can be followed with a straight line with respect to x, okay, obviously. If we graph the point cloud, the corresponding one, we can see that maybe again a parabola will be a good curve to model this situation. And we will do it, okay? We will find a parabola and look for it first. The vertex of this parabola would be close to 60, so let's define a variable change that is t equals x minus 60 squared. Okay, that will be a direct variable change, that will be a good one. Um, Again, in list 3 on your calculator, you can enter parenthesis list 1 minus 60 parenthesis squared, and you will obtain the following values of t. And then you have to perform linear regression on your calculator thanks to the pair ty. So for the calculator, the pair list 3, list 2. So here are some additional results. And finally, the linear correlation coefficient, in which we can see that indeed between t and y there is a very, very strong linear correlation because it's very close to 1. Well, the expression of the straight line between t and y will be this one. Again, if you did well in your calculator, you must obtain these results. And if you did not, just ask me on commentaries. Then we have to perform the variable change or the change of writing in the expression to obtain the expression of the correct parabola. for the first graph that is here on the bottom right. So, 0.00436 x minus 60 squared plus 6.535 is the expression of the correct parabola. I hope it helped. Don't hesitate to ask me questions on commentaries. See you on the next video. Bye.